In this assessment, we're given the total scheme of a unique oxidation of an alcohol. And we're asked to pick out the step in this long sequence that represents the main step that occurs in every alcohol oxidation mechanism. Well, let's remind ourselves of what that step is before we look more closely and try to find out where that exists on this reaction. And here's that step. Essentially, we're going to have some good leaving group attached to our oxygen, which allows a base to come along and remove that proton, form the new carbon-oxygen double bond. That's going to give us the new carbon-oxygen double bond, or the oxidized species. So what we're looking for here is the step during which that new carbon-oxygen double bond forms, and hopefully identifying it as being this acid-base reaction. And so from there, what you notice is that occurs here. Here we have our good leaving group. This S plus molecule that's attached to the oxygen is our good leaving group. We've got a negative charge on that carbon there. That's going to do the acid-base reaction to give this product here. So if I can circle it correctly, I'll say that this is the key step that represents the step that is common to all alcohol oxidation reactions.